Now I'm going to talk about generating clients with Tapir. So who's ever heard of Tapir? Show of hands, please. Okay, quite a few already, which is nice. So first things first, hi. Maybe I should introduce myself. I'm Hugo, and I've been doing Scala for most of my professional career, which is not that long, but I have almost 3 years doing only Scala. I'm a Portuguese developer that just relocated to Switzerland to work in Rivero, which is a fintech startup that actually doesn't do blockchain. And every time I mention this in the conference, people seem to really rally about it, so I thought I would mention it so everybody knows. And as everybody else, we're hiring. And the final thing I believe I should mention about myself is if there's such a thing as functional programming Kool-Aid, I've drank it all because I use all of the cool things. And so today I'm going to talk a little bit first about Tapir, which is a library developed by Software Mill. It does have the same name as the animal. You can see the little mascot over there. And at the end, instead of giving you a minute for you to think about questions, I'll bribe you because I have a few of these. So who asks question gets one while supplies last. So to motivate my problem, I'm going to create a fictitious thing, which is nobody is really happy with their project management tool, at least in most of the companies that I've worked, and I hear people talk about it, but still everyone uses mostly the same tool, but no one seems to be really happy about it. So I'm going to do something about it and create a new thing which has this abbreviation. And if you think about it, maybe you can guess what I'm going to name this fictitious project, which is yet another project management tool. So yeah, maybe you guessed it. So in order to develop this side project, we've heard before that it's better to plan instead of hacking it right away. So I'm going to gather some people to rally with me to build this thing. So I'll have a front end because project management thing should have a front end for you to work with, a back end, maybe I can help with that, and a mobile developer because everyone likes apps these days. And so I'll get Hugo for the front end, Silva for the back end, and Sousa for the mobile. In case you're not aware, that's just me because I cannot really convince anyone to be on this side project before I have anything going on. And so the first thing, if I'm going to create a project management tool, is you need to have some sort of tasks so that people can accomplish and the project actually gets done. So here I created a fictitious case class for a task, which has an ID, a title, a description, and maybe a due date, depends on how you like to work, or how it's configured, or its importance. I don't know, it's up to you. And so if I'm going to have tasks, then I should also have a way to create tasks. And so this is the same thing as a task, except that I don't have the ID because I have not created a task yet. So if I create a backend, maybe the create task will be the payload that I send and I'll get a task back. And so for the rest of the things that I'm going to show, just assume imports out of Tapir, Circe integration as well. And since I'm not going to actually write JSON encoders, decoders, that kind of thing, assume I'm using the auto generator of Circe, which I don't use for anything serious. I actually write the thing, but presentation purposes. And so to get starting using Tapir, I will create a description of my endpoint, because as you've seen in this conference, descriptions are a recurring thing. We want to describe what we're doing, and then we'll deal about doing something following that recipe in some sort. So for Tapir, I want to describe endpoints to get started on my awesome project. And so I start from the endpoint, which is something that gets in from the Tapir endpoint, from the Tapir import. And endpoint is just a value where I start building things on top. So for create a task, my endpoint will be a put. The path, will start with project name, and then a task, just to make the URL more interesting. And there will be a JSON body to create a task. That will be, the payload. And the output would be a task that has been created, but that will be the success case. In case there's an error, I'll just put a string back containing whatever went wrong. And this is not exactly what you would do. Maybe you would get a better typed error that you would think of, standardize on that. But this is just to show you a little bit how you can describe an endpoint using Tapir. So what if, and this value creates task has a show method. If I print it, what happens? It shows that, I did somewhat of what I told you. I described a put endpoint where it has a project name that you can see there that it's a path parameter. And then, task, and it has the body as JSON. But, the create task is just a value. And that value is just an instance of a case class that I've been building with these successful calls. So if I try to print it, you don't need to actually look underneath, but just know that it's a case class that you could actually do stuff upon. And to actually explain the type, if I assigned it to some other val, doesn't matter. I'm just doing it for the sake of typing. I didn't even name it. And so it has 4 type parameters. The first one is the input. And since my URL contains one path parameter, which is a string, which is the project name, it's there as the first part of the tuple. And then the create task, that's the body that goes in the request. So the input is the name of the project plus the create task body that I have to submit in order to make this request. The error is a string because I'm lazy and did it so. The output, if everything goes well, is a task as I've defined earlier. And then there's support for streaming capabilities, which I'm doing nothing about. This is a very simple thing. But if you wanted to have streaming, it's also a description that is supported. But back to my definitions of task and create task, I don't really like them. It's not how I usually build code. Doesn't really take much advantage of Scala besides the case class versus a class. So what I'm going to do is I'm going to create new types for this thing, for every field, because I like to have proper types on everything so I don't mix things up. And so on the companion object of a task itself, I can define types for ID, title, description, and due date. And I'll make them any vals because I don't know if you're aware, but it's something that the compiler tries to do away at runtime, even though it's not always possible. And then my task, every field becomes something that is in the companion object. So you can see the ID, the title, the description, and the option of a due date. And these are just wrappers for the underlying values. And then my create, since I don't need to do it top level, it refers to a task. I'll just put it within the companion object itself, and it'll just refer to the same types, except for the ID, of course. And this type of, specialization that I'm doing, I will call it that. I don't know if it's the most correct term, but this type of specialization that I'm doing on everything that I put on my task and create task case classes, it can be done in quite a few ways. Even though I've used any vals, you can use refinement types, you can do type tagging, and you can do opaque types. Even though these mechanisms are also useful for other things, all of them can cover this use case, and you have some sort of way to encode them easily or not so easily sometimes in Scala. And so let's go back to my create task definition. What I want to do is also type the project name because, yeah, I'm giving types for everything. The project name also deserves one. So what I'll do, instead of just inlining the change, is I'll do it on another val, and since all of these are case class definitions and parameters, things will just compose, so I'll just extract the path out and map it to a project name. What I'm passing there, technically if it looks weird that I'm just passing the project name in parentheses, it is so, it's not a typo, it's not a type parameter. What it is actually being passed is the project name companion object, which is auto-generated because project name is a case class. And then underlying there's a fancy macro which actually does this conversion for us, which is really nice. And then I can just change the previous path parameter that I had into this new one that I created before. So after I defined what I want out of my first endpoint, I need to actually create a backend, right? Because just descriptions is not going to make a project run by itself. Tapir has integrations with a lot of things, and so I'm going to do aka HTTP. Just as an example for you guys, it also supports some other things. So first, some imports. The first two are stuff from aka that you normally see. And then the third one is aka HTTP. And then you have to initialize things. This is not the first talk where you're seeing this. If you've been attending the other talks, it's just part of aka HTTP and the things you need to actually set up a server and make it running. And then I'm adding a final import, which is the Tapir integration with aka HTTP, which gives me an extension method to route. And this I can apply to endpoint case classes. And then what I'm doing here is on my create task definition that I did before, I'm calling toRoute and then creating an aka HTTP route. And because I'm lazy, I haven't really implemented it. The detail of it being a future has to do with how aka HTTP routes work. They're based on futures of results. So it's asynchronous. And then, as you can see, the parameters that I'm mapping over in order to build my response are the project name and the create task. And I didn't write their type parameters, but the project name is what you would expect, and the create task is an instance of the create task case class. And so I'm just going to error out with implementation is missing. And I can put this as a string because previously I've defined my error type to be a string. So this is actually type checked. I couldn't put anything else as the error. And then I'm going to wait on the result of binding the aka HTTP to my local host in order to be able to test stuff. I'm not actually going to do live code. I'm just showing you how things are built, but if you copy paste this, it should work. And as a side note, if I was not building something that requires Scala and some other things, because I wouldn't feel like building mobile and front end on Scala alone, then if it was just Scala, you could also make automatically clients that take this endpoint definition and allow you to make a call to a backend with this definition plus a base URL that you would use in order to know where the base server resides. Before I could start some front end, I would do some documentation. That's what everyone does before starting coding, right? And so Tapir also helps me with that. At first I import the OpenAPI and OpenAPI Cersei YAML, which will help you to generate some documentation, as I'll show you. But first, in order to create some documentation that is actually nice, I have to add a few more things to my previous definition. And so I'm going to do an enriched create task, which at first is just my create task that I had before. Now I'm going to add a description because, once I have an open API thing, it will look better if it has a description. This is for creating a task, obviously. And then since it's a case class, I can just copy and change something. And on the output, I'm going to add an example. And so I can add an example of a task that it would return if it was a successful call. The ID is 42. The title is to present at Scala, something that I should be doing. And also meet cool people could be the description. And then there's no due date that I added to it. And then, out of this new endpoint definition, which has been enriched, I can actually call .to open API, which based on my imports is also an extension method. You will see this pattern a lot when using the Tapir integrations. And I pass it a title and a version. The title is my fictitious project, and the version is pre-alpha because I haven't done anything really. And so if I print that to YAML, it will look like a normal YAML open API definition, which I haven't put all here. I have just put a little bit of it, which is the schema of what I'm doing. And it's what you would expect, but the title, the description, and the date are back to being strings. As in the first definition that I made, they're not types that I specialized. So I kind of lost type information on the process of translating it into this standard, which also gives me other nice things. But I lost some type information, and as the guy that loves everything typed and everything functional, that makes me kind of sad. So the first question would be, why do I care so much about this little thing? Some people might call it little. I would argue not. And so let me take you a little bit back of when I became a professional developer. I got my first job. And let's say that I have a case class of a subscription that has the ID that is along and the user ID which is along as well. And so there's a subscription repository. I'm not going to get into much details, just enough for you to get the gist of it. The find by ID gets an ID. And since this is the same type as both the ID and the user ID, basically this was my first bug in production. I passed the wrong ID to a thing, and it escalated really. It had really nasty consequences within the company. I won't say it on camera, but you can ping me after. The story goes much crazier after this. And so what can I do to, prevent the kind of thing that went back to bite me a long time ago, and I would like to prevent this class of bugs. And so I could settle, just, it's developer due diligence got us so far, let's just keep doing it. I'll settle for this loss of information. I can build it myself, the full thing that generates something different. Or, I could use a schema language that a bunch of those exists. Now at the end, when I got to this conclusion, I was really happy, right? I could, for the payload, combine it with the schema language, galaxy brain moment, and then I would, find a way to glue things together with the rest of the endpoint definition, and that would do the thing for me, and I, would have the things that I want. Well, mainstream schema languages don't really seem to support these kind of mechanisms, and I've checked quite a few, so no galaxy brain moment for me. And so, that got me thinking, am I the only one that cares about this specific thing? Am I just going crazy with the specific thing that I could just get over? And I started looking besides Scala, and then, let's look at frontend, for instance. Well, Flow has support for opaque types, which allows to solve this problem. If you don't know Flow, it's a type system for JS. And if you static type checker and system for JS. And TypeScript has a long-standing PR open for it. It didn't get that much traction. However, you do have a way to hack it in TypeScript as it is currently by adding another field which contains the information, and TypeScript has literal types, so you can match against the thing. If you want then later more information, just ping me about it and I can explain the hack that some people use to get over this. So I guess I'm back to building something to make this work. So here was, that's where the name of my talk came from. I started a project called Tapir Gen, where I would try to solve this problem by myself. So going back to my endpoint definition, and now I've removed the type that I had created for the project name. It's back to the previous old one, just for the sake of simplicity. And what do I need to create a code generator, that does this for another language? Tapir has the definition of an endpoint, but for the types that I will need to create code generation, and if I'm doing code generation, I also need to create the types in the other language, so that then I handle serialization and then calls to something, and that's already sounding like a lot of work and complicated. It's because it is. I'll have to create some sort of definition of a type so that I can bolt it in another language. And so you can think of a definition of a type as the name of that type and some fields that it has. And this is the simple thing where these kind of types that you want to bolt in, and no support for functions whatsoever, because that's not the thing that I'm trying to achieve. I'm just trying to send payloads from one way to the other. And so I create a companion object for that and define the field as you would expect. It has a name for each field of the case class that I have in Scala, and then a type name for that field, because that's what I'll need. And then, I actually want to create this out of case classes. So, I can create this function, which, also needs information about the type, which is why you see an implicit class tag, which the Scala compiler can provide us. And then I can start with, very nasty code with reflection out of this class tag. And then when I have something working, actually make beautiful code that I'm proud to show other people. But, I'll skip the actual implementation of that, because it's not that relevant. And then once I have this, then I can actually create, what could be a code generator for a language that you want to implement a code generator for. So it would just have an apply method where you would pass a namespace, a top level name, the type declarations, which would be a list of the thing that you've seen before, and labeled endpoints, because when you call an endpoint, you would need to know what kind of endpoints you're calling. So if this still doesn't make that much sense, let's jump into an example where I would make a code generation for Scala. I'm using Scala just as an example because you kind of understand the syntax, hopefully. But this would be the dumb one to implement because, with Tapir, I can already have an integration with something that does this for me. I don't need code generation at all. So, my aim is to do it for actual other languages, but for the sake of explaining it to you. So, first I would, find a way to convert the type declarations into the code that I need to generate. Then, I would have to pick some framework or some way to actually call the backend and get a response back and have to generate that code. And then the final thing, I would have a package, and then the namespace would be the name of that package. In Scala, I would make it, with an object with the top level name. And then I would put in the type declarations and then, the functions that actually call that backend. And as I've said before, I wouldn't actually be doing this in Scala, but from here you can get a gist of the most basic code generation that you could try doing it by yourself. If you actually try to do this, you'll see that there's lots of quirks of generating code just by bolting strings together, and it's hard to make something that actually compiles and works properly. So most people actually resort to having more complicated constructs underneath. But if you want to get your hand at code generation, you can get this, and you can, after see it compile, and get the kick to keep you going. So, as I've mentioned, doing it right is not trivial at all. So you have to think about the names that collide between the things that you're providing, because if you have colliding names, it won't compile on the target language. And you also have to worry about the reserved keywords of each language, because if you pass a reserved keyword as a name, you also have a compilation issue. And if you want to do it right, that's not complexity that you want to put on the person defining the thing. You would want it to already have those things acknowledged and be prepared to deal with them. And especially if you're doing this for multiple languages, like the complexity gets bigger and they start not looking exactly the same unless you find a common abstraction, which is not so easy to pull off. And it's a very error-prone process even while trying it, and you get into a lot of things that you're like, I don't really want to be dealing with this, but I actually have to, or else I won't have code that compiles, and that defeats the whole purpose. And so that kind of brings me a love-hate relationship with this project, because it's something that I would like to have, but I really don't like to build it. But yeah, I'm trying at it. And so since this gave me, quite a bit of anger sometimes while building it, I thought, well, can I actually do away with something? What would I actually want to get out of this project? So I thought, well, type safety is the thing, right? That's what got me in the first place, and that's what I want to get. And not just, regular type safety. I want to be able to specialize the primitive types that I have. And the target language, can support any of the mechanisms. It can be something like Scala's any val, it can be type tags, it could be any of the others that I described, as long as they have one of those or something else that allows me to distinguish between, different primitive types with different semantics, then I'm cool, I'll just generate that. And, it would also be nice if it generated open API for me. And I would want, code generation or something that checks that code that is done is compliant. So, how you get that is, I would implement some sort of crazy type checker of my own, or I generate one way or the other into the language or from the language something. And that's how I ended up trying to generate 2 languages. And it would also be nice on top if it could generate documentation pages for me. And so if I, look at Tapir without me trying to do anything special on top of it, it's already type safe. You saw the payload structure that didn't have the primitive type, and I have a typo on the slide that didn't not really. Sorry. So I have primitive type specialization if I stay on Scala. If I leave Scala, then I'll have an issue with that. But if I stay purely on Scala, I'll have type safe. I'll have the primitive types because I specialize because I'm staying in my language. I'll have generation for open API, which I've shown you how it works. I won't have code gen, but if I'm staying in Scala, I don't really need it because I have my descriptions. And Tapir also has a very nice thing of automatically generating pages with the documentation. You can bolt it into Akka HTTP, and you get some endpoints where you can see the Swagger looking like thing, which is also really nice. And what if I try to branch out of Scala and try to combine Tapir with, other tools? Because OpenAPI is a known thing used by a lot of developers using a lot of different languages, and there are code generation things built on top of OpenAPI specification as well as various other tools. So why not to try to take advantage of that ecosystem? Well, yeah, I would get the code generation, so you see that thing is ticked, but I would lose the primitive type specialization because that's not built into the OpenAPI specification. So since it's not part of the standard, there's actually no way for me to hack it in. And so Tapir plus Tapir generation, which I'm working on, and I already have prototypes for a couple languages that are working for all of the endpoints that I tried to define, but I still didn't go all the way with streaming and some other specific things that Tapir supports. I still didn't try to bolt them in, so I should have it working for a couple of languages and nicely to work soon. TM, don't quote me on that, because it's a free time project. And another thing that I have been asked when I was working on this and talking about this with other people is, are you building this only for languages that have a way for you to specialize primitive types? And, well, I can, but I also can not do it and do it for other languages. Let's say that in Scala I didn't have all of those things and just had case classes. I could, build a client that instantiates a case class for each different thing that I need, and then I would have type safety. I just wouldn't have any optimization on that. I would be paying an extra allocation per field in order to have it specialized with something specific. And so if that difference in performance or garbage collection or how extra allocations can affect your runtime doesn't really matter, and you would like the niceness of type safety not being able to pass a wrong ID into something else because they're structurally the same, then I can actually do it for whatever language I would like that actually has static types, and the others, yeah. And yeah, as I've mentioned, this is pretty much work in progress. If you want to talk about help, give me alternatives for not having to build it, I will be very thankful. And of course, I don't have the conditions to continue my side project, so unlike other speakers, I don't finish my side project because things come up. And yeah, that was pretty much what I had to tell you guys. Instead of giving you a minute for questions, I actually have a bribe. So who asks a question will get a Tapir, as long as I have enough to give. And thank you very much to Jacek, I think I pronounced the name right, hopefully, from Software Mill that was kind enough to bring this for the talk. So thank you. And questions?
I have 3 kids, so I have 3 questions. No, only one is okay. So, you said something about streaming. So Tapir supports streaming.
Streaming, yes.
So I can have a method. I can add an endpoint that will return me
a stream of something, yes.
Yeah, and then here's the question, the follow-up. What is, when I generate a client for it, what is the type that I get from that stream? What will be?
So I currently don't have that working still, but it would pretty much depend on the library that I'm using underneath to call a backend. Yeah. So if I'm building, I would have to use libraries that support streaming, you know, because when I'm generating something to call a backend, unless I'm doing it in a language that is all batteries included, I will use, you know, a library for easiness to call a backend, and then I would have to resort to the streaming capabilities of such a library instead of trying to, you know, go crazy and build the world myself.
But then there is no support for stream yet. It's something that's
I'm working on it.
Okay.
Yeah.
And then the next question is, when I have a client, do you have any mechanisms to do service discovery and know where is? Because I'm thinking using that in a Kubernetes setup where I don't know the IP of my service, that I want to find my service by name or something like that. Is there something like that?
I'm only aiming for type safety. Discovery you would have to build in yourself in some other way and then just pass a URL or an IP as, you know, the base thing, and the description, you know, builds in the rest of the URL and makes the correct call to that.
Okay, thank you.
So someone got a mascot. Anybody else got questions? Guess not. People, okay. You also want a mascot.
Is there a GitHub link to check it out?
There totally is, and I should have linked it, but I better walk you through the codes instead of telling you where it is so you don't get scared, because it's still really rough. Thank you. Anybody else? You can talk to me afterwards and ping me. That's not a valid question, so thank you.